Okay, so in this presentation, what we're going to look at is well, actually, I'll start off with the first two questions there. Draw a graph with the degree sequence 4322, and if it's not possible to draw this graph, explain why. And a similar question, 43322, and if it's not possible to draw this graph, explain why. So what I'm going to do is actually, I'm just going to switch over to pen and paper. So 432, the sum of degree sequence is 11. Okay, 4 plus 3 plus 2 plus 2. That's an odd number. Okay, which means a graph can't exist with that degree sequence. Okay, now the reason is it constructively mean 5.5 edges, which does not make sense. Okay, that's the reason why it does not exist. Okay, so the second one is 43322. Okay, the sum of the degree sequence is 4 plus 3 plus 2 plus 2. That is equal to 14. So sum of degree sequence, and that's an even number. So that is perfectly acceptable. So let's try draw this graph. Okay. So what we should do here is actually just at the top of the shot there we have the degree sequence there. So what I'm going to do here is actually just start off with the node with the greatest degree sequence. Essentially work from left to right here. Okay. Give myself plenty of space. Okay. So what I'll do here is I will match up. By the way, there's multiple ways you can get a node of degree sequence there. So let's add that up. Okay. So we have and we could match that up there. Does that work? Yes, it does. Okay. So actually, let's just see where we are. I'm not finished yet, but I have 3, 4, 2 there. I need another one with degree 2 and another one of degree 3. So if I add those together, I'm done. Okay. So that's degree 2, that's degree 3, job done. Okay, the next question asks us to explain what is meant by a complete graph and how is a complete graph with n vertices denoted. So what I'm going to do there is actually just switch over. I actually just wrote this out. So complete graph, each vertex is connected to every other vertex, okay, and by a single edge directly, okay. I'll actually add that word in directly, okay, not indirectly through another node or through another vertex directly. And for n vertices, we would denote such a graph Kn, capital K, sorry, K and subscript n. Okay. Now, so that is the question. The next thing we are asked is how many vertices, how many edges does a complete graph with 8 vertices contain? Okay. So if we have 8 vertices, that means that for each of the 8 vertices, okay, we have a degree 7. Okay. Each of degree 7. Okay. So the total number of edges is 8 by 7 over 2, which is 28. Okay. So I'm just going to pause it there and set up the next thing. So a graph is said to be called k-regular if each of the vertices has degree k. So construct a 2 regular graph with 5 vertices, construct a 3 regular graph with 6 vertices, and construct a 4 regular graph with 8 vertices. So let's just sort of switch over to my page here. So 2 regular with 5 vertices. The simplest actually one in this case would be actually to draw a, let's use red pen here. So to use a chain, okay, or a ring. Oh, not yet. There we go. So there I have each case there. It's essentially a sort of like a perimeter, if you get me. Okay. Now, that's a very simple one. So 3 regular with 6 vertices. Okay. Well, I think actually when you should start off with these, actually just draw out something similar to what I've just done before. So I'm going to draw a bit more of a regular shape this time. Oops, I just messed it up there straight away as soon as I said it. It's supposed to be something like a hexagon. What I could do here is actually, so right now they already have something of degree 2. Okay, so I just have to add in one more edge to each vertex. So what I'm going to do is actually connect each vertex to the vertex directly opposite it. Like that. So there we go. Very simple idea. Okay. There are other ones actually that you could do, but I like that one the best. I don't know. It's just very symmetric and straightforward. Okay, and the final one, I just sort of cut a little bit out there just to sort of condense it a bit, because I just sort of start using an idea I've already created. So essentially what I'm going to do here is start off with a chain, a ring. Okay, so what I have to do here is right now they are all 2 regular, so we need them to be 4 regular. So what I am going to do here in this one is also connect it, as well as, for example, connecting 1 to 2 and 8, I'm going to connect it to the ones that come after that, 7 and 3, sort of double perimeter effect. You can get very artistic here. So let's go there. Boxes within boxes. Okay. Now, perfect. Lovely. Okay. So that's 4 regular on 8 vertices. So that's our question sheet, or this particular question from our question sheet done. So we'll leave it there.